Welcome. In this video, I'm going to show you how to express this function below as the sum of a power series, and then we're going to find the radius and interval of convergence. So before we begin with anything, let's recall a key power series. So the sum from n equals 0 to infinity of x to the n, well, that's just equal to 1 plus x squared, and so on. And so long as the absolute value of x is less than 1, which I'll write here. Actually, here's a better spot. So long as this condition holds, this infinite series here equals 1 over 1 minus x. So the idea is to rewrite this so it looks like this series. And an easier way to think about this might be, well, this x here is this blob, and we want to replace this blob everywhere. So we want 1 minus some blob, and whatever is in that blob is going to go here in all these spots for the absolute value of that blob less than 1. So let's try that. 1 over 1 minus negative x squared. Clearly then this is the blob, our negative x squared, so everywhere I see an x that is a pink highlighted spot, I'm going to write in negative x squared. So this is 1 plus negative x squared plus negative x squared squared plus negative x squared cubed plus negative x squared to the fourth, and I'll stop here. And really, I could have just jumped straight to this step, but right now while you're learning, get into the habit of writing out some terms and simplifying them just to get used to the patterns you'll encounter. So this is 1 minus x squared plus x to the fourth minus x to the sixth plus x to the eighth. And this will just keep going. So I can write this as the sum from n equals 0 to infinity. Now, we could figure out a pattern here, but at least now we have this blob. So what I mean is I could have skipped all of this and just gone straight to here writing negative x squared to the n. But again, it's a good idea to get used to writing out these terms and looking at patterns. And now to rewrite this further, this is the sum from n equals 0 to infinity of negative 1 to the nth power times x to the 2n. Okay, now let's go ahead and find the radius and interval of convergence. Now, to do so, I'm going to apply the ratio test. So to apply the ratio test, we want to find the limit as n approaches infinity of this ratio of the next term divided by the previous term. And so long as this limit is less than 1, then we know that the series will converge. So that's our goal. So let's go ahead and start. The limit as n approaches infinity. Now in our case here, the nth term is equal to negative 1 to the n times x to the 2n, and the nth plus 1 term is negative 1 to the n plus 1, x to the 2 times n plus 1. So I'm going to go ahead and set up this limit. Please pause your video and do the same. Okay, now that you've paused your video, you can see I finished setting up the limit, and I went ahead and simplified this exponent here. So this is the limit as n approaches infinity of x to the 2n plus 2 over x to the n. This is the limit as n approaches infinity of the absolute value of x. Oh, looky here. That should be a 2n, excuse me. There we are, it's fixed now. So x squared. Okay, so this is the limit as n approaches infinity of the absolute value of x squared. And so long as this is less than 1, this limit will be less than 1. Okay, so what does that tell me? The interval of convergence is -1 to 1, and the radius of convergence. Okay, I rearranged my screen just to organize my work a little bit better. The radius of convergence is 1.